Hi everyone. Today we are going to discuss about color of coordination compounds. Generally, when any compound which absorbs the certain wavelength light in visible region and transmits its complementary color in the same region will be appeared as a colored compound. That means any compound which is absorbing the light in the visible region and it will transmit its complementary color, then it will be appeared as a colored compound. To understand this compound, let us come to what is the electromagnetic radiation and what is the visible region and what is the complementary color. As you know, when you come to electromagnetic radiation, it is a combination of the different wavelength lights. That is gamma rays, X-rays, UV, visible, infrared, radio waves. These lights are having the different wavelengths. Gamma rays is having very less wavelength and radio waves are having more wavelength. And when you come to this gamma waves, wavelength is very less means it is having the more energy. Already know that one. What is the relation between energy and wavelength? Energy is equal to hc by lambda. hc by lambda. The energy and wavelength both are inversely proportional. If the wavelength is less, its energy is more. If the wavelength is more, its energy is less. That means gamma rays are having the more energy, radio waves are having the less energy. And in this, only this region is seen by us. That means you can see only the small portion which is from 380 nanometers to 760 nanometers wavelength. It is called a visible light. And when you come to this visible light, it contains again 7 colors. That is called a VIBGYOR. Violet, indigo, blue, green, yellow, orange and red. The visible light is a combination of these 7 colors. So in this, violet light is higher energy light and red light is less energy light. So 380 nanometers, wavelength is less means this light is having the more energy. 760 nanometers wavelength, this light is having the less energy. So from violet to red, the energy of the light will be gradually decreases. Next, let us come to what is meant by complementary color and what is meant by absorbed color. If any compound is absorbing certain wavelength light, for example, let us take yellow light, and it transmits its corresponding complementary light. The yellow light complementary light is the purple. If it is absorbing the yellow light in the visible region, it will transmit the purple color light. The purple color light is called a complementary color and the compound will be this color only, that is the purple color. For example, similarly, orange color. If any compound is absorbing the orange color, it will look like a blue color because the orange color complementary color is the blue one. So like that. So red color, green color is complementary and absorbed colors. Orange and blue is the complementary and absorbed color. Yellow and purple is complementary and absorbed color. So it is easy to remember. You are writing this circle by using the VIBGYOR only. Start from red, yellow, that is the orange, yellow, green, blue and purple. By the combination of the violet and indigo, you can write the purple. So start from here red. I am writing here red, orange, yellow, green, blue, purple. And you write as a circle, you will get the like this combination in the opposite. So that means red and green is absorbed and complementary colors, blue and orange is absorbed and complementary colors, yellow and purple absorbed and complementary color. Means if the red light is absorbed, it will look like a green color compound. If the green light is absorbed, it look like a red color compound. If any compound is absorbing green and orange, it will look like red and blue. If it is absorbing the red blue, it will look like orange and green. So this is the absorbed color and its complementary color. Next, let us come to what is the reason for the complex compounds color. Already know that one. In the complex compound, d orbitals are splitting into two energy levels. D orbitals are splitting into two energy levels. In case of the octahedral, these are split into what is that one, T2g and Eg. And the energy difference between these two is also depends upon the so many factors. For example, let us take here, it is the energy difference between these two orbitals is delta. This delta is having the certain amount of the energy E, and according to this energy, the certain wavelength light is absorbed by this molecule or complex compound, and by absorbing this energy, the T2g level electron will promote into the Eg. So what is the type of the wavelength light is absorbed is depends upon again this delta V. So if the delta value is different, the absorbed light is different. Later you can discuss about this one. Just remember here. So according to the delta value, the certain wavelength light is absorbed by the molecule or compound, and in that the T2g level electron will promote into the Eg level. So like that, it is called excited state. Already know that one, the excited state is the unstable one. So when the electron is enter into the excited state, again it will try to comes back to lower energy level to get the stability, and when it is coming back, it will transmit again its complementary color wavelength light. So it is the absorbed light and it is the transmitted light. So when it is transmitting, what is that one, a certain wavelength light, and depends upon this wavelength light, it will be appeared a color. So every wavelength light is having the its what is that one, colors, and depends upon this wavelength, it will look like a certain compound color. So this is the main reason for the color of the complex compound. That means they are absorbing the light in the visible region and they are releasing the light in the visible region only. So what it may be, released light or transmitted light, according to this one, the compound will be colored. Next, let us come to factors affecting color of complex compounds. So mainly there are four factors affecting the color of complex compounds. Those are nature of metal ion, strength of ligand, oxidation state of metal, and structure. So these four factors are affecting the color of the complex compounds. Let us come to first nature of metal. So when the metal is different, for example, let us take the copper plus 2, chromium plus 3. Copper is a blue color compound, chromium is plus 3, in the plus 3 oxidation state, it is green color compound. So when the metal is different, automatically color is different. So what is the reason? When the metal changes, automatically its electronic configuration changes, and also the energy difference between the two energy levels, two orbitals, T2g level orbital, Eg level orbital. The energy difference between these two is also different. So copper is having the different delta value, chromium is having the another delta value. When the delta value changes, automatically the absorbed energy light changes. When the absorbed energy light changes, automatically the color of the compound is also changes. That's why, so different metals are having the different color in nature. And next, let us come to strength of the ligand. So this is the important factor in case of the color of the compounds. When the same metal is bonded with a different ligands, they can have the different colors. For example, let us take the cobalt. When the cobalt is bonded with cyanide, is orange in color, ammonia yellow in color, fluoride green in color, water blue in color. Same metal. So cobalt is the metal, same metal, when bonded with the different ligands, it is having the different color. Now come to what is the reason. Simple reason here. So when the strength of the ligand is changes, when the ligand changes, the strength is also changes. When the strength is changes, what happens? The delta value changes. Already know that one, strong field ligand. What is the meaning of the strong field ligand? The ligand which is having the more repulsion toward the orbitals. When this ligand is having more repulsion toward the orbitals, it will split the two orbitals into higher energy. And weak field ligand. The ligand which is having the less repulsion is a weak field ligand. It will split the orbitals into less energy. And how to understand the weak field ligand and strong field ligand? Generally, if the donating atom is carbon or nitrogen or phosphorus, these three elements are having a strong field ligand. If it is a carbon or nitrogen or phosphorus, strong field ligand. In case of the strong field ligand, the delta value is more, it will absorb the different type of the light. In case of the weak field ligand, the delta value is less and it will absorb the another type of the wavelength light. That means when the ligand changes, automatically the delta value changes. When the delta value changes, automatically the absorbed light is also changes. When the absorbed light is changes, automatically the color of the compound is also changes. So this is about the strength of the ligand. Okay, next come to oxidation state of central metal ion. So when the oxidation state changes, automatically the repulsion between the ligand and orbital is also changes. So oxidation is different means what happens, the electrons present in the orbitals is different. So when the electrons present in the orbital is different, it is having the different type of the repulsions toward the ligand. For example, when you come to vanadium, +2 oxidation state is having violet in color, +3 oxidation state is green in color, +4 oxidation state blue in color, +5 oxidation state yellow in color. So a simple reason, when the oxidation state changes, electronic configuration changes. When electronic configuration changes, automatically the color of the compound is also changes. Similarly, let us come to structure. So structure is also one of the factor in case of the different colors. So when the structure changes, automatically color is also changes. For example, let us take the NiCl4-2 is green bluish color and NiCN4-2 pale yellow color. Here simple reason, generally the NiCl4 present in the tetrahedral structure and NiCN4 present in the square planar structure. When the structure is changes, what happens? The splitting of the d orbital changes. When the splitting of the d orbital changes, automatically delta value changes. When the delta value changes, automatically the color of the compound is also changes. That means if the different compounds are present in different what is that one structure, they will have the different colors. And let us come to conclusion about the color of the compounds. In general, the compounds which are having the D0 and D10 electronic configuration are colorless in nature, are the white color compounds. So what is the reason? For example, if we take the D0, there is no electrons in the orbitals. If there is no electron, that type of the compound can't absorb any wavelength light because there is no electron to promote from lower energy level to higher energy level. And when you come to D10 electronic configuration, in case of the D10 electronic configuration, all the orbitals are filled. That means when you come to T2G level, EG level, all the orbitals are filled orbitals. When all the orbitals are filled, there is no empty space in the higher energy level to move the lower energy electron to higher energy. So it is not possible. The movement of the electron is not possible in case of the D10 electronic configuration. That's why these are the colorless in nature. That means in D0 there is no electron to absorb the energy, and in D10 there is no empty space to move the electron from lower energy level to higher energy. In these two cases, the energy is not absorbed. That's why these are colorless in nature. And when you come to D1 to D9 electronic configuration, D1 to D9 electronic configuration, these are the colored in nature. So what is the reason? For example, if you come to D1 electronic configuration, so by absorbing the energy, this electron will promote into higher energy level. Similarly, D2 electronic configuration, it is also promote into higher energy level. D3 electronic configuration, it is also promote into higher energy level. So like that, from D1 to D9 electronic configuration, there is a possibility to absorb the energy and to promote the electron from lower energy level to higher energy level. So that's why these compounds are color in nature. So D0 to D10 electronic configuration is a colorless compound, and if any compound is D1 to D9 electronic configuration is a colored compound. Thank you.